algorithm. So Euclid division algorithm, what does it says, and why this is a division algorithm, what is the meaning of this word algorithm, why division is included, all these answers, all these questions I am going to answer after doing an example. So first of all, there is an application of this theorem. This algorithm is used for computing HCF of two positive integers. I am saying computing HCF of two positive integers. Not only for two positive integers, you can find the HCF of 3, 4 or any number of positive integers, and we can also find the HCF of negative integers except 0. I'm saying we are going to find the HCF of, we can extend this theorem up to negative integers also, but 0 is not included. So we are going to find the HCF of two positive integers using Euclid division algorithm. Later we are going to find the HCF of 3 positive integers or 4 positive integers using this algorithm. So the first example I am included, this is there in your NCERT book, which says find the HCF of 4052 and 12576. 4052, this is 4052 and 12576. I'm quite sure that nobody ever tried to find the HCF of 4052 and 12576 using prime factorization, because the process is very long process. I'm not saying that we cannot find the HCF of these two numbers using prime factorization. We can, but the process is very long process. So in order to save our time, we are going to use Euclid division algorithm. So how it is going to compute the HCF of 4052 and 12576? So let's start. First of all, 4052 is a smaller number and 12576 is a bigger number. So we are going to divide 12,576 by 4052. So the first number, which is 3. So if we multiply 4052 by 3, so our product is 3 2 is 6, 3 5 is 15, 3 4 is 12. 12,156, and the remainder comes out to be 0, 2, 3. So remainder is 320. Since here you are saying this process is also done by you in your previous classes, where 12576, that is 12,576 is your dividend, 4052 is your divisor, 3 is the quotient, and 320 is your remainder. So this is the process where dividend equal to divisor into quotient plus remainder. So here dividend is 12576, which is equal to divisor, that is 4052 multiplied by 3, and remainder is 320. So our first step is this. Since the remainder is not equal to 0, so we are going to continue with this process unless we get remainder as 0. So now we are going to use 320 as a divisor and 4052 as a dividend. So now our divisor is going to become dividend. So 320 is going to divide 4052. So 320 is going to divide, sorry, it's not 320, it's 420. So 420 is going to divide 4052. So 420 9 ja 90, 92 ja 18, 94 ja 36 or 137. So remainders comes out to be 2, 14, 7, and this is 9. 9 minus 7 is 2. So remainder comes out to be 272. Again the remainder is not equal to 0. So we are going to continue with this process. 272 is now our divisor, and the dividend is 420. So now 272, 1 ja 272. So remainder is 10 minus 2 is 8, 11 minus 7 is 4, and 3 minus 2 is 1. So our remainder is 148. So again the remainder is not equal to 0. So 148 will become divisor, and our dividend is 272. So 148 1 ja 148. So 12 minus 8 is 4, 6 minus 4 is 2, and 2 minus 124. Again remainder is not equal to 0, so continue with this process. 124, 1 ja 124. So here the remainder comes out to be 24, which is again not equal to 0, so it will become our divisor. So 24 divides 124, so 24 5 ja 120, remainder comes out to be 4. Again it is not equal to 0, so 4 divides 24, and since 4 exactly divides 24, so 4 6 is 24, and here the remainder comes out to be 0. So since the remainder comes out to be 0, so we stop this process, and the divisor of our last division, the divisor of our last division is the HCF of 4052 and 12576. So HCF of 4052 and 12576 is 4. So in this way we are going to compute the HCF of 4052 and 12576. After finding the HCF of these two numbers, write all the steps. So our first step is 12576 is equal to 4052 multiplied by 3 plus 420. Similarly 4052 in the next step is equal to 420 multiplied by 9 plus 272. In the third step 420 is equal to 272 multiplied by 1 plus 148. In the fourth step our 272 is going to be 148 multiplied by 1 plus 124. In the fifth step 148 is equal to 124 into 1 plus 24. In the sixth step 124 is equal to 24 into 5 plus 4, and in the seventh step 24 is equal to 4 into 6 plus 0. So the HCF comes out to be 4. So that is why I am saying this is an algorithm. Now I am going to tell you about what does Euclid division algorithm say. Euclid division algorithm, it include two words, division and algorithm. I think you are right now you know why this is the word division is included, because it all include the division process. And the another word is algorithm. Algorithm actually is a step-by-step process of solving a problem. So here our problem is computing HCF of two positive integers. I am again repeating, our problem is computing HCF of two positive integers, and we are going to compute the HCF of two positive integers by following a well-defined step-by-step process. The first step is to divide 12,576 by 4052. Since the remainder is not 0, so we are again repeating the first step, but in the second step the dividend and the divisor, they are going to change. The divisor of the first step is going to become our dividend, and the remainder going to become divisor. So in this way we are going to find the HCF of 4052 and 12576. So this is why this theorem, this whole process is known as algorithm. So Euclid division algorithm mainly is used to compute the HCF of two positive integers, and it includes a lemma which we are going to learn in the other classes. So right now I think this process is clear. So now it's your turn to find the HCF of two positive integers. So I'm going to give a questions of finding the HCF of 135 and 225 using Euclid division algorithm.